City Rail Link is set to open for passengers in the second half of 2026.
Auckland's eagerly anticipated City Rail Link is now set to open in the second half of 2026, the government and Auckland Council have confirmed.
New Zealand is joining the Underground Rail Club, and it's doing so with a price tag of more than $5 billion. For a city with a population of merely 5 million people, this is a lot of money to bank on one project. But the city's rail system has been struggling to keep up with the demand. And with more people choosing public transport over cars, this decision was long overdue. This is the story of City Rail Link and what it took to build it.
The City Rail Link has the potential to transform Auckland from a city where you can't survive without a car to a modern city with fast, frequent, stress-free public transport.
To understand why New Zealand spent $5.5 billion digging holes through the middle of its biggest city, you have to understand what Auckland's rail network looked like before this project started. The old system had one fatal flaw. Every train had to pass through Britomart, the central city terminus, and Britomart was a dead end. Trains came in, stopped, and had to reverse back out the way they came. That design capped the entire network at roughly 12 trains per hour in each direction. No matter how much you expanded the outer lines, no matter how many new carriages you added, the single point was always going to be a problem. The City Rail Link fixes this permanently. By connecting Britomart to the existing Western Line at Mount Eden through a new underground loop, the network transforms from a dead-end terminus into a proper through-running system. Trains no longer have to reverse. They flow continuously. And that single change unlocks 24 trains per hour. That's double the old maximum, and there's room to grow even beyond that. But building a loop through the middle of a live city is not a simple thing. Before a single tunnel boring machine went into the ground, engineers spent years studying what was actually down there. And what they found was complicated. Auckland sits on one of the world's most unusual volcanic fields. The city is built on top of roughly 53 volcanic cones, and the rock beneath it is inconsistent, unpredictable, and in some places, particularly near the waterfront, not rock at all. The land is reclaimed, fill material dumped into the sea over a century ago to extend the city's footprint. That fill is soft and waterlogged, completely unlike the basalt you find just a few hundred meters away. So, the tunnels had to navigate two completely different geological environments, which include hard volcanic rock and waterlogged fill soil, where the ground itself could shift and collapse if pressure wasn't maintained perfectly. This is where the tunnel boring machine comes in. The star of the show. She weighs 2,100 tons and she's 10 meters long. Her cutting head is 6.8 meters in diameter, and her name is Dame Whina Cooper, named after the revered Maori land rights activist. Dame Whina Cooper is what's called an earth pressure balance machine. The technology is specifically designed for urban tunneling through unstable or waterlogged ground. As the cutting head rotates and bores forward, the excavated material, called spoil, is kept under controlled pressure inside a sealed chamber. That pressure counteracts the natural ground pressure outside the tunnel wall, which prevents the surrounding soil from collapsing inward and stops the surface above from sinking. In a city, surface settlement is critical. If the ground above the tunnel drops even a few centimeters, you can crack building foundations, damage utilities, or destabilize roads. Dame Whina Cooper was lowered into a launch box near Mount Eden in pieces because the machine was too large to move any other way, and then assembled underground. Her first tunnel drive ran northward toward the CBD. Then she was extracted, craned out, and prepared for the second parallel drive. That's already 2 tunnels, each one 3.4 kilometers long. She moved at an average of 10 to 12 meters per day. Every meter she advanced, concrete segments were installed behind her to form the permanent tunnel lining. But the TBM didn't build everything. 2 of the 4 new stations, Karanga Hape and Te Waihorotiu, required a different technique entirely. And for these stations, they use cut and cover construction, where you dig down from the surface, build your structure, and cover it back up. It sounds straightforward, but in the middle of downtown Auckland, with live traffic above, functioning businesses on either side, and a web of underground utilities threading through every cubic meter of soil, it is one of the most logistically complex things you can attempt in civil engineering. On Wellesley Street, the main construction zone for Te Waihorotiu station, the project team had to maintain traffic flow while simultaneously excavating. They did it in stages, installing steel ground anchors horizontally into the surrounding soil to hold the excavation walls, while digging proceeded in lifts, one level at a time, downward. And what they built at the bottom of that hole is extraordinary. Te Waihorotiu station sits 32 meters underground. That's roughly the depth of a 10-story building, inverted. And the design brief was architectural. Auckland wanted something that felt like more than a train station. The station draws on the Maori concept of Waihorotiu, which is the freshwater spring that once ran through this part of the city before colonization buried it. The design responds to that history. A 90-meter skylight shaft cuts through all levels from street to platform, pulling natural light down into the deepest parts of the station. The interior architecture is meant to mimic water moving through rock. From a structural standpoint, that skylight is a feat of engineering in itself. Punching a vertical opening through a structure at that depth, while maintaining the structural integrity of every level around it, required precision reinforcement work that had never been attempted at this scale in New Zealand. But every mega project has its crisis point. The City Rail Link had several.
The City Rail Link is not only a day late and a dollar short, $1 billion over budget and several years late.
The COVID-19 pandemic hit during a critical phase of tunneling. Supply chains for specialist equipment needed for the project froze, and skilled labor availability collapsed. The project was already expensive by New Zealand standards, and the pandemic added cost and time that no risk model had anticipated. Then came the geotechnical issues. Auckland's volcanic geology is well documented, but the ground still found ways to surprise engineers. There were pockets of material that behaved differently than predicted. Groundwater intrusions and sections where the tunnels ran close enough to existing building foundations that every meter of advance had to be monitored in real time. There was also a moment during excavation of the Aotea station box near Queen Street where workers discovered significant archaeological material. The area had deep historical significance, and work halted while heritage assessments were completed. On a project this scheduled, every delay compounds. Despite all of it, the project held together, and the end is in sight. The City Rail Link is currently in its systems integration and testing phase. The hard excavation work is done. What remains is the installation and commissioning of rail systems, and then the testing phase before it carries a single passenger. Testing on a project like this is slow by design. You run the trains, stress test the signaling, simulate emergency scenarios, and find the edge cases and fix them. You run the trains again. The system cannot open until every variable has been validated, because unlike a road where a pothole causes an inconvenience, a failure in an underground rail system carries consequences that escalate quickly. The target opening is late 2026, and when it opens, the benefits will be many. The network today can run 12 trains per hour through the central corridor. After opening, that number becomes 24. Existing stations on the western and eastern lines like Henderson, Papakura, and Manukau will see increased traffic without any additional infrastructure investment. Auckland's rail patronage was growing consistently before the pandemic and recovered faster than most transit systems afterward. The City Rail Link was designed for a city that is still growing, projected to hit 2 million people within the next 2 decades. The tunnels being bored today are carrying that future population. New Zealand is a small country. Its cities are relatively modest by global standards. And for most of its history, it is built like a country that assumed cars would always be the answer. The City Rail Link signifies a shift from this. It is an argument that Auckland's future cannot be built above ground. that it's a city trying to compete with Sydney, Melbourne, and the world at large. And in 2026, when the first train runs from Britomart through the new underground loop and emerges at Mount Eden without stopping, without reversing, without waiting, that decision will finally be visible. And here's the thing, Auckland isn't alone. Cities all over the world are doing the same thing right now, digging under their own streets, spending money they don't have yet, and building for populations that haven't arrived yet. Sometimes it works, sometimes it doesn't. So, I want to know what you think. Is underground rail the future for growing cities, or is $5.5 billion a price tag that just doesn't make sense when most people still drive? Drop your answer in the comments below. If you want to see more deep dives into the infrastructure projects quietly reshaping our world, subscribe. We've got more coming that'll genuinely surprise you. And if you watch this far, you're exactly the kind of person who'll enjoy the deep dives on our pages.